Hey guys, welcome back. Here with another Macintosh keyboard hacking live with got some fun project here today. Today we're going to be looking at doing some upgrades, some mailbox upgrades. What does that mean, you ask? Well, let's say we've got something like this. Um, This is part of a community network that I put together, sort of in the aftermath of the hurricane came through. I was kind of fortunate to have, uh, my spectrum came up, several weeks before, other parts of the street. And prior to that, I was able to configure a Linux cell phone uh, tethering thingamabobber. So, just try to, kind of share the fortune. Another thing that's been kind of fun to do, with this community network is the distributing the video. So again, I've got a fancy antenna system, uh, and now in this wireless distribution system, uh, it gets it out there from the HD home runs and file servers and so on and so forth. So that'll be fun. Essentially, what I've got the I'm using a pair of Ubiquiti nanostations. The one on the left is the Loco model. It's got half the one on the right has twice the antenna gain, and also a pass-through PoE port. So that's pretty cool. But yeah, out of the box, they run Ubiquiti's own sort of Eros thing. It was based on OpenWRT very, very, very long time ago. Ubiquiti likes to try and take advantage of technical capabilities of like the chipsets and stuff that they're using. So they were Atheros, excuse me, Atheros, centric for a very long time. So you see they focus on a lot of features like variable channel widths. And they have their own sort of TDMA as a time division uh, method of access. It ensures fairness. So yeah, so they do a lot of cool stuff. I like them because they're cost effective. They seem like they're not especially Chinese, and yeah, they do a great job. So this model comes with a it came with a little passive PoE power supply. Um, all of the prior models required that. This is the first of the nanostations that allows you to use like a standard PoE power supply. I'm not using that capability because having a radio outside in a tree, I'm not really comfortable having a copper connection back to my fancy switches. So they're on the other end of a fiber, and it's sort of a cost optimized thing there. But network's been in place for a little while. I've got signal strength graph here, just of the main link down the screen, street rather. This is using the radios are now running OpenWRT. It took a little bit of time to get those compiled. Ubiquiti is required by the FCC to implement roadblocks in your ability to change the firmware. That's an issue with software-defined radios. Maybe now that whoever's in charge, they'll just close the FCC and it'll be, just like Russia. But anyway, yeah, so been graphing, the signal strength. It's been pretty solid and reliable, except for that period of time where I forgot, that the power went out or something. Uh, so we can see that there's been a recent drop in signal there. In order to support this sort of field trip, I actually turned the transmitter power on my head-end router up. I turned it up to what should be 60 milliwatts. Normally, I only run at 15, and it's enough for the link. And this link, I'm using the 802.11 AC capable radios, but in 802.11n mode. because that's just kind of where it fits on the reception. I don't have quite a good enough signal to warrant AC. And those are all just the head-end radio. One of these files. Yeah, just using a host APD. That's a common Linux, access point thing. So it's been perfectly stable. Like I say, it took a little time to get that compiled, but and so just to kind of point again, how the apparent signal strength went down when I turned up the power. That's a common symptom, I guess you'd call it, in wireless. You wouldn't really think, but in just about every case, in so many cases, lower power will characterize itself as a better signal because there's less noise involved. So here we're looking at the data sheet of the radio itself. What we see here is that, okay, so these are the 802.11, the two rates that were added for AC. So these 256 QAM modes. So we take it, to even transmit in an AC modulation instead of an N modulation, we lose 2 dB of output power. And as you see as we go down, let's see, it's 72. Wow. Yeah, 72, 54, 48, I think. We lose power basically until we get down to this base 64 QAM mode, which is 24 megabit. So just because your chipset is capable of, high speed, AC 1200 or whatever it is, and because it's capable of high power, in this case, 25 dBm output, they're not generally capable of both of those at the same time. So when it comes to building like a stable, consistent network experience, like I say, if you're relying on that full transmit power, you can't plan on anything greater than 24 meg. So again, I've been operating these at 15, which would translate into 17 dBm, I guess. So that's, I couldn't get a full AC modulation, without taking a power hit. And so then you see, but however, the same things, you lose half of your range in the first step of the AC modulation. And then you lose like another, 3/4 of your range. Access to those higher modulation orders, the efficiency takes a hit. So while there's definitely, you don't really want to be running 6 meg or anything super slow. Yeah, so these are great. They've got good patterns. I guess this is the one that we actually have, but I think the numbers are about the same. So yeah, was able to get Linux on there. There's some nice functionality in the stock Ubiquiti firmware. If you're building a truly, private network, and you're just using it as like the wireless is like an Ethernet replacement, or if it's a unified, if it's all their stuff, it works pretty well. No, I would not like to change my password. But this is, an access point that's used. It's willing to peer with range extenders if anybody wants. But just as 2.4 gigahertz access out there. This is an older, it's an M series. It's a much older Ubiquiti series, but we'll see this in person when we take a trip down the road here. It's a Pika station, I guess this is. This is the last version of the firmware that allows for something, but I don't remember what that is. Yeah, okay, compliance testing. Yeah, that's so if I go into my frequency, no, that doesn't look very interesting. Well, So there's that, and then I've got an additional one. We refer like to the, so that was the Pika station. It's got a vertical omnidirectional antenna on, and then I've got a another NanoStation 5. It's an older model. Thank you. That sits sits on the other side and offers out a different variant of service. And this one, there's something special about this one. I think we're on channel 165 there. So so that lets me get a little bit above that. That's actually once upon a time, some of these hacks like going out of band were illegal, but I mean technically now, and those bands have been the regular 802.11 AC has been expanded to include those frequencies. So what was once ill-advised is perhaps a little less difficult. Yeah, it definitely goes out of band because 165 is the highest 20 megahertz channel you're going to get. And there's some real nice, there's a Java-based spectrum analyzer built into that, which is cool, but I've got to find something that will actually log into that. I think I got to be on like Windows XP or something. So this is not the one I want. I want this one. So and then in this case, there's a a small managed Netgear switch out there as well. Not currently doing much. Future plans include trunking stuff over VLANs. But I think VLANs will be more relevant once I get to a larger client base. But it does support QoS on Ethernet frames, and it's nice to be able to see status of the number of packets sent and whatnot. You can use it to it's got a cable test function. So one of these, I think 4 or 5, is actually my power feed using a single Unify power supply to run all of this stuff. Yeah, so and then the 46 meters actually is the cable back to my power supply. I don't usually. That's another user of the system, and they don't normally connect while their own charter is working. But the network is kind of available as a backup. I do have a Starlink on the roof, not currently subscribed, but and sometimes my network just works better. So managed switch, you're able to. I kind of wish it was a real PoE switch because then it could be used to power cycle. But I think this switch, it was in the Amazon used thing for $15. So for managed, Netgear is about the only thing I really trust in consumer electronics anymore. Consumer networking stuff. This thing. All right, so so there's a whole network out there. That's that managed switch. Essentially, this network has been in place for several months, about 6 months, more than that. And it's just sort of starting to show its show a little bit of wear. The waterproofing has kind of fallen apart, and so could use a little bit of upgrade and clean up there. So I think I shall run down and take a first-hand look at it. I've been putting it off for a while. Every time I drive by it, it's like Oh, I need to. Oh, look at all the tapes falling off. So let's take a little field trip. See if this works.
Hey, all right. So there's something. Oh, that audio is bad.
It'll take a second to get that squared away here. All right, that seems a lot more manageable. All right, let's see. Got some handy dandy supplies here, so we'll see what we find. Not sure how clearly I fully thought through the logistics of what would be involved here, but let's start by taking a look at the way I do other networking things. So this is the equipment that serves the head end here, and then we'll get that visual shortly. So a couple of fiber converters and a homemade. I got a cheap PoE injector looped back into one of those Netgear managed switches. So that works pretty good. What I didn't figure out was how to mute this receiver during annoying carrying. Well, just have to persevere. So, all starts here. Got a little station up in the tree and just delightfully placed cable. Alright, there we go. That's, I think we're all back where we want to be. There's a lot of moving pieces. So we'll just, enjoy the walk down to the tower site. It's a nice day. You can hear the cicadas making all kinds of horrible noise, as they do. So this is untested, so I'm not sure, whether to expect myself to be audible or not. I'm sure I'll have to flip the AP on the other iPad, not the face one, but the application one, because that screen mirroring chews up a lot of bandwidth. But yeah, nice day, a little windy, pleasant breeze. All right. Not a bad walk, but, a reasonable hike for a wireless network there. Let's take a little look-see. And so then this is the actual implementation. I found that cheap brown packing tape was, a fairly good color for simulating wood. But this guy over here really, just kind of looks tacky. Like I mentioned, the managed switch there is, getting kind of wet. So, gonna tidy that up a little bit with some paint and whatnot. Looking on the other iPad, it says I've got a signal. A couple of bars anyway. Let's see what a speed test. Now I don't know how well it's going to work to speed test, the very Wi-Fi I'm trying to AirPlay on. So get ready for breakup. That's not really realistic. So let's pop over then. Let's see. Looks a little bit better. Really here denominator connection, so. Well, I got an error message. Hopefully this is all still working. But I won't try anything more bandwidth intensive. But yeah, I'm going to take a moment and get some spray paint and put some tape and try and make this all beautiful. And while I do that, hopefully you can see this, this old archive footage of back when Starlink worked and I knew less about IPv6, so enjoy! Hopefully that didn't leave everybody at dead air for too long, but it took a little longer than expected, but from a distance, from the street, that's packing tape. It's not exactly beautiful, you know, something. But that was the intention, kind of get out here and just do that upgrade. Oh yeah, I had also wanted to look at the signal strength, so let's see if that part is still working. Uh, Says it's on. Alrighty. Let's take a little look at airport utility. Wow, that was fun. A little bit of a hike. At least now I don't have to worry about the rain. No immediate loss of connectivity. Looks like our little traffic blip right there. But yeah, fine. I know it works. Oh, that's not a good sign. No, that's a good sign. Guess that's just an ignore it sign. Because 30 is the IP of the switch down the street. Yeah, 21. Well, they didn't like something. That's usually a Cisco. Ding. Yeah, something about that ARP timeout is not right. Or gets forgotten by the network. Well, I guess I will just put it back how it was. About that. All right, well, this was fun. And yeah, thanks everybody for checking in. And hopefully, yeah, we're excited by our mailbox upgrades. The finest in mailbox technology. All right, I'll see you later, guys. Bye.